All right, in this lesson, we're going to be looking at the ideas of ratio and proportion, and at the end we're going to talk a little bit about scale factor. The majority of this should be a little bit of review for you, but again, some of it's going to be new information. Make sure we are writing down our notes throughout. So the first thing we're starting with today is obviously a ratio. What is a ratio? Most people think of it as it's just a fraction. But a ratio, again, always is going to be, it's in the same units, so we always have to have feet to feet, centimeters, millimeters, inches. And it can be written in any of these three. It can be written as a colon, read as A to B. It can be simply just written out as A to B. And lastly, and probably the most common way, it'll be in fraction form of comparing A to B. Again, ratios are always a comparison of something. So, to begin, let's talk about how we would deal with a ratio. So in this problem, I have said that triangle, JKL, and I want to relate the angles in a ratio of 1 to 2 to 3, meaning each angle is going to be bigger than the other. So an example of this would be from this one, from 1 to 2, you should be thinking right now in your head, well, that means I need to double the size. And then from 1 to 3, that means I need to triple the size. So how are we going to do this? An easy way to do this is to treat, since we have 3 angles, we can talk about those angles as x plus x plus x. And right now in your head, you should be thinking about, okay, what is the measurement of 3 angles in a triangle? Student number C. Good, student number C, thank you. The measurement of the interior angles of a triangle is 180 degrees. So all we have is 3 x's right now, but how can we talk about those x's in relation to a ratio? Well, since we know it's 1 to 2 to 3, we know that this first one, this 1, it's going to be by itself. So, and we kind of already have that with this x right here. So our second ratio is, we have this 2. And so our first ratio would be 1 to 2. And that means our second angle would have to be twice as big as our first angle. And right now all we have is this solo x right here. So if it's got to be twice as big as our original x, what number should we put out front of this second x? Oh, good, well said. So that would have to be 2x. And then I hope by now you can figure, I just burped, excuse me. You can figure out what this last one would be. So in other words, I said this last one now, down here, we have to go from 1 to 3. So in order to go from 1 to 3, that second one, this 3 right here, would have to be 3 times as big as our first one. So that x would turn into 3x. So now it's just a basic problem. So we have x plus 2x plus 3x. Good, thank you. Yep, that would be 6x equals 180. And then if we just simply divide both sides by 6, we're going to get that x equals, I think that's 30. Well, how can we relate that back to our problem? Well, we had a ratio, again, we're back up here, we had a ratio of 1 to 2 to 3. And we said that was x plus 2x plus 3x. So that means our 3 angles, we could say that angle J is 30. That's our original x. We could say that angle K is, we'll do this one, it's 2x, so it would be 60. These are degrees all. Don't forget your degrees. And then the last one, well, we have angle J and we have angle K, so now we need angle L. And well, angle L would be this 3x, or this, our 1 to 3 part of our ratio. So angle L is probably going to be, well, 3 times our 30 would be 90 degrees. Any questions? No, you can't. You can't ask questions. I don't know if you realize that or not. Okay, so moving on now. Now we're talking about proportions. What is a proportion? Well, a proportion is simply 2 equal ratios, or a comparison between 2 ratios to make sure they are the same thing. And whenever we're dealing with proportions and we need to solve for proportions, there's this concept you learned in algebra last year. And in class, some of you are telling me you don't remember this. And you've never seen this before. Well, I asked your English teachers. Your English, we're not in English class, guys. We're in an algebra class. Last year we were in algebra class. Cross product property. This is what we use to solve in proportions. We're going to use the cross product. Again, proportion, comparison between two ratios. So let's look at this one. Here's our first proportion. So we have two ratios. So our first ratio is obviously this 4 over x, number one, first ratio. And our second ratio here would be 5 over 7. And you're thinking to yourself, holy cow, what in the world do I do? It's a really great question. I'm going to answer that question for you right now. We are going to take the cross product, better known as cross multiplication. So we're going to cross multiply. We're going to take our top number here, and we're going to multiply it by our bottom number here. You see cross, and the same thing here. See, it makes this cross, this x, and the product, if you can see, it makes a big X, and what does that X always represent for product? It represents multiplication, so we're going to cross multiply. So 4 times 7 gives us 28. We have this equal sign still in the middle. That's got to be there. So we cross multiply, we still have that equal sign. On the other side, we're going to have 5x. Okay. Then if we want to figure out what x equals, we would just have to simply divide by 5. So our x value to make our two ratios the same would be x equals 28 over 5. And I'll tell you what, for funsies, tomorrow in class, someone better tell me what the decimal representation is of 28 divided by 5. This is one that was stumping a lot of people when we did this one. Whoa! Holy cow. That is 2 variables. I don't know what to do. That's why you have Mr. Loshaw. You're welcome. What do we do? The same thing. We need to cross multiply. So our first one, 3 times y, well that gives us 3y. And now if we cross multiply here, we have y plus 2 times 2. Well, let's leave that as 2 times y plus 2. Oh boy. With parentheses, what are we going to do? I believe, if I'm not mistaken, we take this number on the outside of the parentheses and we have to multiply it by both numbers inside the parentheses. So we're going to have 3y equals 2 times y is 2y plus 2 times 2 is 4. So now, if we're just solving, we should just probably subtract 2y from both sides. So 3y minus 2y, that's going to leave us with this singular y. And now all we have left on the right side is, 4. Oh, look at that. Y equals 4. So if we want to check our answers, why don't we do that? So if we check our answers, so instead of y, we're going to put in 4 plus 2. And instead of y, we're going to put in 4. And what is 4 plus 2? Well, it is 6. And is 3 divided by 6 the same as 2 divided by 4? Or is 3 6 the same as 2 fourths? I believe they are the same. Good job. Thank you. I appreciate it. All right. Any questions, comments, concerns? You'll have a chance to ask those in just a moment. One more problem with the proportion is now a word problem. A blueprint shows an area of a room as 5 by 8 inches. The actual room is 20 feet wide. Holy cow. 20 feet wide. How tall is it? Boy, that is a good question. It's such a good question. I'm going to leave this one for tomorrow. Please write this problem down, and I would like you to attempt it. This is the problem we're going to begin class with tomorrow. Yes, don't give me that guff. I can hear you. Mr. Loshaw, get over it. So make sure you're copying this problem down. You can use the pause button if need be. Try and figure out how tall it is. Good luck. The last thing I want to cover in this lecture today is the concept of scale factor. Well, what is a scale factor? That's a really good question. A scale factor is, and SF stands for scale factor, so take a look at this. You see SF right here? Well, that stands for scale factor. That's cool, Mr. Loshaw. Nice job. It's a really good abbreviation. The ratio, at which one object is larger or smaller than another object for all measurements is the scale factor. A scale factor is just going to be a ratio. And if I'm going a little too fast to cover the notes, you have that pause button at the bottom left part of your screen. It looks like this. Don't be scared to touch it. So here we go, scale factor. Wow. So I want to know the scale factor between our two objects. What is the scale factor? In order to find a scale factor, we just need to take one similar side of one triangle, or one object, I'm sorry, to the other object. So if we look at our object, we know that this side and this side are the same sides. Yes, they're not the same size, but they're the same side. One of them is proportionally different. So in order to do this, we're just going to take our big one. So we need to know, the question was, what is the scale factor of A to B? Well, our A side length is 9. That's a 9. Our B side length is 6. So the scale factor from A to B would be, well, what is 9 over 6 reduced to? Oh, good student number 5. 3 over 2 is our scale factor. Uh-oh, got an announcement coming.
Russ Roker to the main office, please. Russ Roker.
I don't have that as a student,
Also,
so.
Jared Decora,
That's
Logan Heath, Austin
holy
Nelson,
cow, a lot of people.
Justin Fuller,
Oh, geez.
and Colvin.
I'm going to lose like my whole class right now.
Penquin, Garrett Goodwin,
Okay,
Jordan Brown.
okay, well, thank you. That's good to know. Anybody got to go? No, you don't have to. Last. So, if I asked you for I asked you earlier, what is our scale factor then from B to A? What would our scale factor from B to A be? Well, it would just be 2 over 3. Do not forget now to go onto the Skyward online quiz and fill out the 2-question one. Come with the problem I asked you for tomorrow about the rectangle. There's the bell. That means I got to go. It's been real.